while we are on a break. One thing, of course, the obvious thing, if you're going to do some interactive exploration, of course, quitting, let me see again, is well, right? So quitting is halt, not exit or quit, right? Halt. Okay, that's Prolog for you. They figure they use their own different wording, but yeah, quitting, of course, Control C would also work. And also, if you run a program, you can do this SwiftPL, right, on family PL. That also would work. You don't have to, right, until we can check grandparent, right, I think XY, right, you should get all of them, right? Albert Brian, and that's it actually, right? So Albert's Brian, so only it's using one fact for itself, right? Yeah, again. Right, so again, the interactive way is probably easier, right? So you running this would be easier. Now, let's see something in more action. So again, halt, we can quit this, right? Right, so pretty easy to load file. You can do the consult, or you could do it also directly. Also, if you have time during this lecture, we will see if you can install the actual, see how it would run on a notebook. Theoretically, you could run this, make your own notebooks, like I'm using Python. You could run Prolog as well. You have a Prolog kernel instead of Python. But that is unfortunately not very well supported, not much documentation on that. So more Prolog info. So let's explore this, the syntax in more detail, maybe a little bit more. All right, so we have it. So let's take a look. So facts, rules, right? So queries. So unification. So recursion, right? So there's a lot of recursion happening, right? So right. So let's take a look ancestor, right? So let's do something with more. So let's define. Let's do some recursion. Recursion can be used to define ancestor. Right, so let's see if AI does this for us. Okay, yeah. So this would be the first one, right? Ancestor is, somebody. So A is answer to D, right? If if they're parent, that makes sense, right? Right, obviously answer, but of course you can also define recursively, right? So you got second implication, right? Parent, yeah, X, there is some X, right? And then which of course parent is something to X, and this somebody is also ancestor to D, right? So now the question is that enough? And that should be enough, even if you have. Let's add some more rules actually to this, right? That's good. Let's add somebody. So Albert, right? There's somebody. So parent. I don't know. Dino is parent to Albert, right? So Dino is the parent to the Albert. Albert is parent to Jim or and Peter, right? And of course Peter is Jim is Jim has a person. So Dino is also ancestor of Brian, right? Right. Okay. Right. So now if you run this, right, add extra. So you have three levels. So grandparent, of course, you can define. It's easy to define great grandparent, right? Let's do that as well, right? Let's also define great grandparent. Let's define great grandparent. Let's define great grandparent. Great. This should be basically right. In fact, that's why I'm doing it, right? We only have grandparents, we have parents, so you have GGP, right, has GP and GB, great grandchild, right? So, all right. So these are like very specific rules, right? But you see this one here, ancestor, this should work. Let's take a look, right? Let's see if we can find. So maybe I'll copy this, all of this, I'll copy it, override this here. Where's my notebooks? Where are my notebooks? Now, here we go, right? So I'll copy Control R, Control V, right? Let's run this, see if there are any mistakes. There might be. No mistakes, no obvious mistakes. So again, you see, by the way, look at this. I like this. This notebook's pretty nice. It tells you it's a recursive call, right? Obviously it is, but that's nice. So let's take a look. So first of all, let's check. Do we have any great grandparents? So great grandparents, right? parent any GGP, right? Any GGC, right? Of course, and these are just totally open-ended variables, right? So let's take a look. Yeah, Brian Dino, right? There should be more, right? How about Anna? Of course, and I think that's it, right? That's it. Okay. So now let's replace this with ancestor, right? This should give us any ancestor. This should give us a lot of answers, right? You know, ancestor, right? You know, A on descendant, right? Any A, any D, any descendant, right? Now let's take a look. Oh, sorry, I have to write Control Enter. Control Enter works, but the Control Enter works, right? Or run. Control Enter. So Dino Albert, okay, that works because that's exactly the. Let's do more. I'm lazy. I'll do 10. Right? Look at all these facts. Descendant. Peter, Albert. Right? So Dino, right? Jim, Dino, Brian. So it works. It works. So let's do more. We have 10. Already have 10 ancestors. Right? Again, you could add in your whole family tree and get all the answers. All right. Very good. Very good. So I will add. So this program is already to our files here, right? Family. What else do we want? So we could add, of course, sister-brother relationship, right? Or or we could say it's a girl or boy, right? Female, male, or girl or boy, right? Or other, and so it's also possible to add those facts. I mean, so it's extremely open-ended system, right? So let me update this. Added more family facts, more family facts. All right. Now let's see. Okay, let's see. What else? All right. See it updates. No. Let's look at something a little bit more complex. And this is a notebook I made last year. This is actually a classical puzzle. Who owns the zebra, right? Or who owns the fish, actually, right? It's like, I think, I remember, it's like I was in 4th grade or something. It's a puzzle. Who owns the fish, right? But it actually, there's like 5 houses, right? Let me give you the idea. Classical who owns the fish puzzle, right? Who owns the fish, right? Or it's called Einstein's puzzle, right? Logic puzzle, right? You might have seen this, right? So who owns the puzzle? 5 houses, 5 guys, right? They drink, they smoke, they have a pet, right? They have a color house, right? So British occupies the red house, right? So you want to answer who owns the fish, right? So lots of house. So you could do this by, of course, it's kind of fun to do it when you are, right? It's not, of course, Einstein's puzzle, of course. Einstein had nothing to do with it, I'm pretty sure, right? But it's kind of fun puzzle, right? So the thing is, right? You can do this we can apply this, right? We can find solutions. So we need to define a couple things. Well, this is actually probably next week already, right? We'll do a list comprehension actually there, right? So that's actually maybe I don't want to go to lists yet, right? So this actually does require a list, right? So I don't want to really jump into it. Maybe we can sort of like, well, I guess let's leave that for Thursday actually, right? But see, we can do more basic facts on. That will be next week. So containers we can talk about. So hello world, we did that already. So right, you can also load facts also, right? Declarative facts, unification, right? Modules, right? Relationship we have, relationship program, right? Parent, new parent. Okay, yeah, let's define an aunt and cousins and aunts and uncles, right? Yeah, let's do those. Cousin and aunt, right? So let's add those facts to the world. And again, it's the rules. So rules, you could say, okay, these are okay to add later, right? Order of facts doesn't really matter, right? So sibling, do we have sibling? We have sibling rule, right? So aunt or uncle is basically if they have sibling and the sibling is a parent of whatever child their child, right? So and cousins of course is their parents are siblings. Really easy, right? Makes sense, right? Let's add these. And then we can answer who is the aunt, right? Or uncle, right? And it's trivial to add the extra fact who is actual aunt or uncle by adding the gender, of course, fact. Now let's do this here. Let's add here. Let's run it. And now we can ask aunt or uncle on any you, I call any you, any nephew, any nephew, or niece, or nephew, niece, right? Any nephew, right? And not of course niece, any niece or niece. I can't spell niece. Niece, no, niece, right? That's correct. Doesn't sound right. Or it's like this, yeah. And nice, niece, right? Nephew, right? All right, let's take a look. On right, Jim and Anna, right? So Jim, Anna is aunt to Jim. Does that make sense? Let's look at the facts. No, any niece? No, aunt and Jim is Jim, right? Because Peter, his brother, right? His brother's child is Anna. Let's do all 10. Peter, Brian, that's it, right? Vice versa. Peter is uncle to Brian. All right, that makes sense. And so about cousins, right? So cousins, right? Again, same thing, right? Cousin. Any C1, any C2, right? Of course, I can use shorter names. Yeah, so Brian, Anna, let's do all of them, right? So Anna, Brian, vice versa, right? Okay, well, so pretty simple. If your problem statement has some facts and has relations, then you might say maybe Prolog would work well here. Because I mean, if you had do this, if this type of thing you had to do in another language, right? Let's say in Python, right? You had to do some sort of search. You had to come up with your own algorithm, right? Not so easy, right? In a larger database. So let's see if we can find anything else we could add from the basic introduction. Let's see. Let's go to official site actually. Right? Maybe still go here. Right. Right. On tutorials, beginner, getting started. We saw that already. Right. Learn Prolog now is a classical one, right? This is actually kind of old. So getting started, we did this, right? Yeah, through like. Yeah, like I showed you, right? You can also do command line, right? So we can import likes, who likes who, right? And you can also, so if you want to do it interactive, you have to do assert, right? Edit, listing, stopping, halt. Okay, so this may actually help, right? Now, if you want to do, let's do something a little better now. So tutorials, beginner, learn Prolog now, right? So facts, rules, and queries, right? Some simple example, right? Yeah. So woman, oh yeah, so this of course has Mia, Jody, this is from, right, Jody plays air guitar, this will be of course Pulp Fiction, looks like to me, right? I think so. Yeah, there's gonna be some Pulp, yeah, Butch, Vincent, yeah, this is a Pulp Fiction example, but same thing, right? So, right, Vincent Marcellus, right, Honey Bunny and so on, right? Right, so, again, we can have it. These are not so very interesting yet. We can of course his parents. I mean, maybe cooler facts, but same thing. Right. Now let's see Prolog syntax. Let's explore this a little bit more. Right. So, yeah. So let's maybe look at the basic atoms. Right. Is basically string of characters. Right. So again. Like the smallest unit in most programming languages, like Prolog, the smallest unit that works together, basically, right? It could be variable, right? It could be It could be a fact, could be, you know, a part of the fact, right? So numbers, right? So numbers aren't, again, the kind of thing is, funny thing is, yes, there is, how do you do math in Prolog? Let's do some math. It's not really usually done, but you do it, you can, right? You sometimes need to do some math in Prolog, right? So, let's take a look here. Let's do some math, right? Let me see here. Variables, numbers, right? So how would you do? Let me see here. I think there is built-in predicates. So yeah, we didn't talk about yet the number of built-in predicates. Meaning, let's take so 3 Prolog built-in predicates, right? Right, meaning things you can do. So it's kind of like built-in library, right? So let me look at it here. Right, arithmetic, right? So not considered important. Like it's kind of funny, right? Not considered important, but you can, right? Optionally compiled, right? So, right. So let's take a look at this, right? So sinus of pi. So add. I believe you could do. Let's see if this works. Right. It doesn't matter if you have any. Yeah. So if I do something like this, I think, let's see, add 5, 10, 15. I forget now how it worked. Now, what happens? I don't think it's built in, right? Undefined. Okay. I think it was like this. Is 5 is 3 plus 2? No, that doesn't make sense. Okay, is 3 plus 2? I forget now. Let's play like this. Is undefined. Let's take a look. Oh no. Okay, A. Okay, yeah. So this kind of not really. So A is 3 plus 6, 4, right? I think this is okay. Yeah. Let's take a look. Yeah, it works. Okay, so that's how you do math. That's one of the ways of doing math, right? Obviously, you substitute the value, right? And what happens, of course, the logic engine, okay, technically just evaluates this and then it assigns to this variable, right? So the question is what happens if you have a 7. Let's try to take a look at this, right? Let's add a fact, right? Let's do a new notebook, right? It's not really part of what you know, we'll call it new notebook program. Let's do a bit of math in Prolog, right? So what happens if I do this? If A is 7, can we do this, right? All right, and then what happens then? If I do a fact like this, kind of silly fact, right? Can I do, well, actually, A, right? Is this actually going to work? Let's take a look. Oh, no, you can't do that. Like, so you have to do operator here. So, yeah, A is 5 plus 10, right? I'll do it one more time. A is 15. Let's take a look. No, it works. Okay, so it works, but it's not really, like I said, if you, I kind of want to warn you against this. If you try to do it like a regular program, it won't work. So this is the wrong way of going. I mean, it basically, sort of math is sort of like secondary to this. The logic is more important in this than, so you can do it, you can squeeze in, right? But it's not really the main thing. So you can get the values right out, right? But it is not like the straightforward, right? So you don't really use it. So you can of course make questions. For example, you can say whether between, right? So kind of still, for example, you can do this. Successor, right, is 5 after 4, I believe. That's correct. Call, I believe, function, right? Oh, come on. Yeah. Oh, 4, 5. Oh, true. Okay, that's good. So yeah, this is kind of bad program, so I'll Yeah, true. So successor, right? And if I do it successor 6, it will not be because it's not directly, right? So again, if you want, you can check all. There's a bunch of stuff built in, right? Uh, type so loading all of this built-in predicates. There's quite a few of them, right? Right. So you can open up also files. You can write two files, right? So you can add extra modules if you want, right? So file system interaction, you can actually save files, right? File directory, right? So again, you have to call the predicate basically, right? File directory name, right? So again, is there such a directory, for example, right? Exists directory, right? So delete file, right? So let's see what else do you want to check here today first. Exception handling, control predicates. Yeah, so how about sort of like if else, right? Again, it's not really, I mean, you don't really use if else here. I believe there's a way of usually, so like if you find yourself using if else as directly like that, it's not really well needed. Okay, so character representation, that's another thing, right? Used to be that this is another problem. UTF-8 support was a problem with Prolog, but now I think it's fixed. I hope it is. There's char code, char and byte, right? So if you're doing Latvian or some other language, it might be an option, right? Might be problem. So loading, we already checked that. Load files, consult, ensure, like these are all built in. Now, let's see, what else do you want? Finding all solutions, right? Find all, right? All right, so find all. Let's run this program. Right, where's my family program, right? I'll load again, right? So, cousin, right? It works. And let's do find all, right? On the right. So we need to find all solutions. So let's see if we can do this here. Bag template. Find all template. What we want to find solutions and goal on where you want to put it. Let's take a look. Template. Can we do this here? Listing foo. Foo. Let's see if we can do this. Let's see if we can get the correct answer to this. Right. So find solutions. Right. Find solutions. State. Let me see if you can find this here. That'll be tricky again. Well, maybe something a little bit easier. So numbers, atoms, variables, we call it complex terms, right? Again, you can do also, of course, we can do nesting again, kind of like, not like, kind of like closure, right? In a way we could do something, father, butch, for example, here, recursive structure, right? That's completely allowed, right? Now let's do one more. So batch the killer, right? Let's see, wizard Harry, right? I guess you could do one of these little exercises. This would be easy, right? Maybe let's take a look at this one here. Let's do one more. No. So simple wizard is a Ron is wizard. Harry has a wand. Which plays Harry. So question is, of course, is Harry a wizard, right? So he has a broom, right? Well, so question is Harry a wizard, right? all wizards, right? So wizard drawn, right? Obviously this is the correct answer, right? Ah, is that a mistake? Ah, oh, okay. That's actually that's another thing. Yeah. So this should be better. This would be better. Right. This, right? Yeah. Let's rewrite it. Now let's check this again. Stop. Yeah. Oh, that's it, right? Only one drawn. So how about Harry? Is he gonna be is he gonna be a wizard? Question. Right. What do you think? It's not defined. The only way is if he has a broom and he has a wand, right? So Harry has a wand, okay, but does he have a broom? What do you think?
Yeah, because he's a Quidditch player.
Yeah. So there's one more step basically, and this should be no problem for Prolog, right? To find out. There's another step. So all Quidditch players have a broom. Harry plays Quidditch, so then of course he has a broom, so he's a wand, so obviously he's a wizard, right? So let's take a look. It should be correct. It is true, all right? So what's the girl's name? I forget now. But she, of course, she's not here, right? So she had to be entered, right? So wizard, so Hermione, right? Hermione, of course, right? So she would have to be entered, right? So she's not going to be here because, well, she's not there basically, right? So if she was a Quidditch player, right? Would that be enough? She doesn't actually play Quidditch, right? But if I remember correctly, but right. So that would not really. She has a broom, right? So we could ask, has broom, right? Has broom Hermione, right? She should. True, right? But is she a wizard? Unfortunately not, right? And she's false because obviously she does not have a wand, right? So she should get a wand, right? Has wand, and again, they say like I said, in this particular instance, these facts, the order, I mean, is not that crucial. I mean, it's only for finding answers will be important, right? So wizard Hermione now should be a wizard, right? But of course, yeah, again, it mentions you should put the facts together. The clauses, right, should go like this. Should go like this. That's better. Right, so that will be a better improvement, right? So has broom, right? No, or we have two inference rule, rule. Pretty simple. Now she should be a wizard. She's a wizard and everybody is happy. Alright. Okay, that was a simple exercise. Anything else? Anything more interesting we could add today? Maybe one more thing. So practical thing, right? Right. So listings, yes. You can load knowledge base, right? Let's do one more. I think up front. Right. Version. Right. So list arithmetic. Okay, let's see the arithmetic, right? So we need, yeah, so yeah, so like I mentioned, right, so you can do this. So x, right, so again we saw that. Yeah. So let's do this. Right. Add 6 and double. So this is how you can do math. Let's do math. Oops. And like this. Notebook. Right. So add 3 and double, right? So how is this gonna work? Add 3 double, so how are we gonna use? So add 3 and double, right? So it should work both ways, by the way, right? But this is where it gets tricky, right? Because if we supply 10, right, that should be 26, right? And then y, you know, or z, whatever, right? z, right? It should be 26. Right? That should be easy. It is 26, yeah, piece of cake. Now the other way will be hard. I think it will just say, okay, it does not know the solution, even thought. So what number? So meaning 10? No, sorry. So x and 26, right? So going the other way, it's not that smart. It might work some things, but I don't think it's going to work here. We can try, right? Because it seems like, okay, you know how to solve this right by now, but Prolog does not have this. I don't think it has this knowledge. But let's take a look. Maybe I'm wrong. Maybe it has better. It has improved it. Yeah, amounts are not sufficiently instantiated. So this is that. This means basically, you see, it tries. What happens? How it tries to solve? It keeps creating bunch of stuff. It keeps trying different stuff, right? So it does not have a this. The other way, the logical inference doesn't work. Not in Prolog, right? So basically, you get this. If you get this type of error, arguments are not sufficiently instantiated. This means that you're probably doing the wrong. You're trying to find something in the wrong direction, basically, right? So because it does not know the formula for this, right? So how about I wonder. Okay, so let's do something simple, right? Is double, right? Is double, right? Or Control Z. Let's do Control Z. Let's do another fact. Is double, right? Again, x y is fine, right? But is x is y, oh, sorry, y is x plus x, right? Maybe this will work. I don't know, right? So let me run the notebook. So if I do it here, 500, I should get 1000, right? Is double. Okay, dot. Yeah, it works. So if I do it the other way, x and say 100, right? So what should be the answer? X should be 50, right? But I don't think it will work. It will say again, we'll get the same error, I'm pretty sure. But let's take a look. Yeah, you see, we tried to add two values and it just failed, right? So the order, what you're asking, hey, it's a okay rule. Y is x plus x, right? It's a predicate, right? So all of the action happens through the predicates, basically here, right? So the correct order is important. So again, for this arithmetic, right? So you would use them. You would use these by having variable the first argument, right? Second, yeah, no, sorry, having constant first argument and variable second, right? Of course, you could do this. Is 50 double of 100? That's no problem. That's true, right? That's solved, right? Again, so the order matters. Order matters, right? Now, doing some more serious math, you need some recursion, right? Factorial. Let's start. Okay, yeah, we have a few more minutes. Let's do a factorial, right? Let's do a factorial, right? It might be built in actually. Let's do math. Do math. More family. And now let's do some math. Arithmetic. We'll call it math BL, right? Let's do factorial. Let's do a factorial. Is factorial. Yeah, so this will be, of course, not like, yeah, is factorial. 1 factorial of 1 is 1, right? So the solution, of course, is just like in other language, you do a recursive, right? So how would you define the second rule? Would be is factorial. Okay, so this gets a little bit trickier, right? So what do we do? So nf, right, that's a result, right? So it's more than 1, right? N is more than 1, and 1 is n minus 1, right? We have to find another fact, right? Now, is factorial n1 is f1, and f is n times f1, right? So the order, this looks okay to me, but the order might trip us up. Let's take a look if this actually works. It looks decent to me. Right. So factorial, right? So let's run it. All right. So is factorial, let's say 5 and x, or result, or t, whatever result, right? X, right? So it should be 120, right? I think. It works. Is there any more? Nope. How about 7? Works? Works. How about 10? That will be a big number, right? Will we do overflow? Let's do 100. It will probably break. Let's break this interpreter. Let's break it. That will get a big number. Oh no, we didn't break it. Look at it. It has a big num support. Oh, look at all these zeros. So pretty nice. So certainly at least recursive steps, you know, pretty decent. How about Fibonacci? Right, that will get tricky. Or maybe we should do Fibonacci for next time. I don't know. Well, look, let's try. Maybe A is good. Let's do Fibonacci. Is Fibonacci, right? 2, right, is 1. 1, 1. Okay, those are easy, right? And now will be the problem. I know what's going to be the answer, right? Yeah. So this is bad Fibonacci, right? So this is bad Fibonacci. Above is looks, smells like a naive. Yeah, we don't do tail recursion, right? So, but let's take a look, right? We'll do a tail recursion in a moment. So see, this actually works, right? So you can see, do you know the problem? Again, this is more of algorithms question, right? So what's the problem with this implementation? You guys know why? What's the problem? I don't like this. I don't like this part here. So what's the issue here? Right. This looks okay. These are decent facts. First item is 1, second is 1, right? These are true facts. First Fibonacci number is 1, second number is 1. How about the rest? Well, the rule is n over 2, okay. N1 is n minus 1, okay. N2 is minus 2, and then you check, right? You're checking true facts and check if they are f is true, right? So basically what you're saying, either this one is true, that one is true, or next one is, so let's say it's 3. Right, n is 3, it's over, so this is true, okay. This is, so what is a comma? Comma is conjunction, and basically. So comma stands for and basically in this logic, right? So n is over 2, okay. N1 is n minus 2, okay. N2 is n minus 2, so these are of course given, right? So, and you check, and then you check final fact, f is right. So, let's check. Is it gonna work? It looks gonna work. So let's see how far do we get. That is Fibonacci. Let's do 10. 10x, right? Let's take a look. Oops, too many open queries. All right. Oh, I need to stop some stuff. All right, let's stop it. Okay, 55. It certainly looks like okay. So 1, 1, 3. No, sorry. 1, 1, 2, 3, 5, 8. 13, 31, 34, 55. Looks okay. If you do 11, it should be 89, right? Oops, Control Z. Yeah, okay. So it works. But I have a feeling, let's double check on like 20. I think it's going to break. 20 will still work. Yeah, but it's kind of slow. How about 30? I think it's still not going to work, but maybe I'm wrong. Yeah, you see? That's bad sign. That's your recursion going amok, right? It's not being properly, right? I should probably board. The sun is not really shining here, or whatever it is. It's not the sun. I think it's a gear symbol, I guess, right? So the issue is why? Because of these extra recursive calls. So for each run, you have 2 recursive calls, right? So it's trying to match too much, and it's going to stop. I'll abort, right? So yeah. So that's something to maybe fix for next time. Maybe see if you can do it next time. Next one. No. Above implementation will not work on values past say 30. Yeah. Okay. To do tail recursive implementation. Okay. Now. So, what did we learn today? We learned the basic syntax. So what do you think of Prolog so far?
Interesting.
It's very interesting, exactly. The word is interesting, yeah. Keyword is interesting. So some things are very simple in Prolog, and some simple things are pretty hard in Prolog. But next time, On Thursday we will look at lists and some data structures, some more complex data structures. List is like the basic one we will be using. So thank you, and I'll see you guys Thursday, or some of you I'll see you in the next course.